Hi, I'm Trish Damkroger, Vice President and General Manager of High Performance Computing at Intel. I am thrilled to be talking with you at this year's ISC about accelerating the possibilities with HPC. With HPC and AI convergence, as well as HPC democratization via the cloud and other solutions that bring more users and more use cases to HPC systems. HPC is everywhere now. Every day, new users are dreaming up new ways to use HPC systems to tackle more and more HPC and AI challenges. The stories are fascinating and inspiring, like manufacturers using HPC to design better performing sports equipment, railroad companies using hosted weather prediction to avoid derailments, pharmacists using machine learning to pinpoint harmful ingredients in drugs, energy companies simulating the lifetime of plant machinery to improve operations and maintenance without drastically increasing cost. The combination of more data, users, and workload types means performance requirements are more varied than ever. So in serving these diverse HPC users and their products, we can't just focus on one aspect of performance, like CPU speed, memory capacity, or I/O. That's why at Intel, we've developed a portfolio of HPC products that provides a flexible platform for success, whatever your project looks like. Our portfolio spans general-purpose compute to specialized acceleration, unique persistent memory, and exascale-class storage, high-performance interconnects, and innovative security capabilities. New this week, we announced commercial support for Deos, our innovative HPC storage product. We also launched high-performance networking with Intel Ethernet, an HPC fabric using Intel Ethernet 800 series adapters, Intel Tofino-based switches, and our next generation of proven fabric software, ported to Ethernet with scale and application performance for HPC AI fabrics. In the 20-plus years that Xeon has been driving HPC, our users have seen generations of innovation, including vectorization optimization, sub-NUMA clustering, and built-in AI acceleration in every CPU. Our latest third-gen Intel Xeon scalable processors, announced in April of this year, provides users just that, innovations in performance and flexibility, with a massive generational leap in performance for your HPC systems. That's thanks to improvement in our core architecture with a 20% jump in instructions per clock, plus increased cache sizes. We're now offering up to 40 cores with 8 memory channels, and 3rd Gen Xeon is engineered to deliver 6 terabytes of system memory capacity. Xeon is still the only x86 CPU in the data center with built-in AI acceleration, and we've also built in flexibility features, like our unique Intel Speed Select technology that basically delivers 3 CPUs in one, so you can meet the needs of more diverse workloads with a single CPU. And here's the impact of those features in terms of performance. 3rd Gen Xeon outperforms AMD's EPYC Milan for a wide range of applications. You can see some examples here. Monte Carlo, for example, runs over twice as fast on Xeon's 32 cores than Milan's. In finance, that means getting your pricing results in half the time. And Relion for Cryo-EM shows a wide lead on Xeon as well. We are also seeing a 50% increase in performance against comp on AI workloads. Let's take a closer look at AI performance on 3rd Gen Xeon Scalable. In this demo, we're looking at accelerating end-to-end machine learning and data analytics pipelines with frameworks and libraries optimized for Intel architectures using the Intel OneAPI AI Analytics Toolkit. Just one line of code change can deliver higher performance on AI workloads, as we'll see. Here, we're measuring end-to-end performance on a U.S. Census dataset using our newly launched 3rd Gen Xeon Scalable processors. And by end-to-end, I mean data loading, data pre-processing, model training, and inferencing. The system on the left is running out-of-the-box software, and the system on the right is running Intel-optimized software stacks with the Intel OneAPI AI Analytics Toolkit, which includes the Intel distribution of Modin, extremely optimized for data distribution and computation, and Intel extension for scikit-learn, which has been optimized to harness the computing power of existing and emerging Intel hardware for machine learning applications. As you can see, the combination of Modin and scikit-learn optimization delivers a 10x speedup. We're proud that Intel's investment in the software ecosystem and optimization such as this one can help data scientists and developers see major performance improvements and be able to scale instantly just by changing a single line of code. Now, let's take a look at how 3rd Gen Intel Xeon compares to the competition. As you can see, our competitor's latest 64-core Milan CPU processes this workload in 33 seconds, whereas 3rd Gen Xeon Scalable needs only 27 seconds. This is a 20% performance win for Xeon Scalable, and at fewer cores than Milan. That's the power of Intel DL Boost combined with our optimization work I just described. Since most data scientists don't run just a single AI workload, we also chose a broad set of 20 popular machine and deep learning models to benchmark against our competitors and saw a 50% performance edge for that geomean. We are so thrilled about the adoption we've been seeing for our 3rd Gen Intel Xeon Scalable processor across our ecosystem. We can't wait to hear our customers' stories and about how 3rd Gen Xeon is helping them expand their HPC possibilities. Several of these customers and partners will be presenting at ISC. Be sure to visit the Intel HPC and AI Pavilion to see our full slate of talks and demos. And I'm not just excited to talk about our Xeon processors, I'm also excited to talk about our latest updates to our Xe architecture. Critical to the HPC market, our XeHP-based products are in the Intel Dev Cloud and being used for software development with customers like Argonne National Lab, where we're co-designing and validating exascale class applications for performance on multiple architectures. And finally, XeHPC-based Ponte Vecchio has powered on as in the validation process, progressing nicely. Ponte Vecchio is our GPU for exascale and AI. It uses 47 different tiles integrated into a single package. This package is a diverse combination of more than 100 billion transistors, manufactured in multiple process technologies and packaged using both Foveros and EMIB. Ponte Vecchio is a petaflop-scale AI computer easily accessible to developers through Intel's OneAPI toolkit. Ponte Vecchio will be available in an OAM form factor and an Intel-branded subsystem with a x4 configuration, serving the scale-up and scale-out capabilities required for HPC applications. Working with and investing in the global ecosystem of HPC developers and users is essential to preparing for the future of HPC. We are seeing broad adoption and impact across the ecosystem for the OneAPI cross-architecture development platform. OneAPI is the productive, smart path to freedom for accelerated computing from the economic and technical burdens of proprietary programming models. With support for NVIDIA GPUs, ARM, Huawei AI chipsets, NERSC, ZIB, and other supercomputers, we are seeing momentum building from the community as well as industry. And Intel's Dev Cloud and tools enable developers to get started right away on Intel's XPUs. Intel's OneAPI toolkits provide compilers, libraries, and analysis tools that enable Intel hardware's latest and greatest performance and capabilities, such as AMX, VNI DL Boost, and memory technologies to power your applications and workloads. Let's hear how some of our customers are using Intel's latest Xeon processors in OneAPI. The University of Cambridge is a great example of using the new Intel Ice Lake 3rd Gen Xeon Scalable processor and OneAPI as part of their Open Exascale Lab. To tell us more about it, please welcome Dr. Paul Kalija, Director of Research Computing Services at the University of Cambridge.
Thank you, Trish. Good to speak with you again. So, yes, the University of Cambridge Research Computing Service provides large-scale UK national HPC resources to a wide range of world-leading science, engineering and medical projects. For over a decade, we've relied on Intel as the foundation for our HPC program. This continues today with a new 600-node 2 petaflop system based on third-generation Xeon technology, which goes into service later this month. Here we see Intel as a vital long-term partner at Cambridge, investing in our community through systems development, training, and access to new and emerging technologies. One fantastic example of this partnership is a major new investment from Dell and Intel into the Cambridge Open Exascale Lab, where researchers collaborate on next-generation systems and can explore emerging technologies that will benefit not just the largest supercomputers, but also HPC systems of all scales. Lab users can access our 10 petaflop system to develop code for Intel GPUs using OneAPI and get help optimizing applications for both CPUs and accelerators. They can also investigate extreme scale storage systems like Intel Deos and work with cutting-edge high-performance Ethernet fabrics. So our vision for the future is to ensure that next-generation HPC platforms can tackle even larger problems than they can today, and that these solutions are accessible to a much wider number of users. Thank you, Trish, and have a great ISC.
Thank you, Paul. And since we are talking today about accelerating the possibilities of HPC, I wanted to bring my good friend, Professor Dieter Kronzmüller, Director of LRZ, to talk about their most recent announcement with Intel.
Thanks, Trish. Glad to be joining you today at ISC, and sorry I'm not there in person. LRZ supports groundbreaking research and education across a wide range of disciplines. Our users tackle some of the most important and difficult computational challenges in the world today. Intel is a key partner in this effort. We build on Intel portfolio and we will integrate their diverse architectures and innovative memory and storage to ensure that LRZ is ready to support our HPC users' success today and tomorrow. We recently announced our plans to expand SuperMOOC NG to address new demand across multiple fields, with physics and medicine to the humanities. This means even more powerful computing, to be sure, but also support for multiple XPU architectures and innovations in high-performance storage. For computing, Intel is providing the blended environment we need, with next-generation Intel Xeon scalable processors, codenamed Sapphire Rapids, with built-in acceleration for new HPC and AI workloads, plus Ponte Vecchio, Intel's upcoming GPU. Since our users need to access data as quickly as possible, we'll be using Intel Deos for fast, high bandwidth, low latencies and high IOPS storage on a system with third-generation Xeon processors and Optane persistent memory. It is exciting to plan how this will deliver improvements in diverse areas, from biomedicine to astrophysics. We're looking forward to see what new projects this system will make possible. Thanks, Trish. Glad to be joining you today at ISC and hope to connect again at SC21.
And speaking of our next-gen Intel Xeon scalable processor, Sapphire Rapids will bring to market innovative and industry-leading capabilities on data center platforms designed to propel customer-relevant and complex workloads. The unique capabilities Sapphire Rapids will provide for accelerating HPC and AI workloads include breakthrough memory and I/O capabilities with DDR5 for I/O-bound workloads. Sapphire Rapids will deliver high throughput, double the I/O bandwidth with PCI Express 5.0 compared to PCI Express 4.0. Furthermore, the Sapphire Rapids platform will offer next-generation I/O with industry-standard Compute Express Link CXL 1.1 support, enabling advanced use cases across compute, networking, and storage. In addition to memory and I/O advancements, Sapphire Rapids is optimized for HPC and AI with a new built-in AI acceleration engine called Intel Advanced Matrix Extensions, or AMX. AMX is designed to deliver significant performance increases for deep learning inference and training use cases. Additionally, the next-gen processors will offer new hardware-enhanced security and virtualization capabilities to increase data and platform security and provide agility and scalability for broad software optimizations. And as part of the Sapphire Rapids roadmap, I am excited to announce that for the first time today, that Intel will provide a version of Sapphire Rapids with high bandwidth memory, which boosts memory bandwidth available to the CPU to significantly improve the performance of memory bandwidth sensitive workloads. Our customers who have previewed this feature are excited about the capabilities. As you can see, Intel is accelerating the possibilities in HPC across the entire portfolio, with Intel Xeon as the foundation of HPC and AI, and delivering heterogeneous architectures including XPU, storage, memory, software, and more that allows our customers the flexibility to grow with the demands and challenges of today. I want to thank our partners and customers who continue to rely on us and our 20-plus years of innovation in this HPC space. Be sure to check out the roadmap presentation from Jeff Waters for additional details of our announcements, including more details about HBM. I also encourage you to head to the virtual Intel booth for additional presentations, fireside chats, demos, and more. I look forward to seeing you all in person soon. Thank you and have a great ISC.